Hey guys, Kodak here. Welcome back to the workbench. Today, an interesting one. Went round to the local Jaycar, which is one of our local suppliers for electronic bits and pieces here in Australia, has this thing called short circuits, which appears to be a whole bunch of kits. And when you buy stuff, you get a list of. So it almost reminds me of the old Fun Way to Electronics, books 1, 2, and 3. But anyway, wandering around, having a play around, and I noticed it's this one. So, focus, yeah. So it's a light scanner chaser project. Apparently, it's an impressive display using 20 LEDs that chase forwards and backwards, just like scanners seen in space movies. Okay. So 12 volts DC, and a whole bunch of bits and pieces. So, yeah, there's a couple of interesting chips in it. So all that. As you can see, the instructions are basically a parts list. There we go. Parts list and a thing which says go by the book if you want the instructions. Want to download them? Project specific instructions or the book short circuits. 3. Yeah, okay. Who cares? We can figure it out. So there's a circuit board. The silver screen's pretty nice. That's pretty good. Easy enough to understand. You need to put stuff, so I don't really need instructions or anything. So first off, here is the back of the circuit boards. So power comes in here. We have the 555 up here, and a thing called 7104 here. LEDs at the bottom. So if you look at that, your circuit board, 555 here, 7014 chip here, resistors, transistors, and LEDs, and a switch up here. So first off, I went through, identified the positive rail, and identified the negative rail running through here, and then figured out that each of these transistors actually switch a pair of LEDs on and off. So you know, this one, these two, this one is that one and that one, that one is that one and that one. So yeah, so it moves them in pairs. And basically, yeah, power rail coming in, 330 ohm resistor, which is here. So all the LEDs share a common 330 ohm resistor. Then you have LEDs in pairs, and then we're running through a, what's it say there, a 548 transistor. And these here then go off to the 7014 chip up here. So there's 10 of these pairs of transistors. So 10 transistors, 10 pairs of LEDs, and with a 10k resistor in each leg. So you've got one 10k resistor per digit. And when you apply a voltage here, they turn on, and you turn the voltage off. The other way around. There. When you apply a voltage and pull this above the base above this, it turns on. When you drop it down to 0, it turns off. So you can then, the chip can then turn them one on each time. 7014 is an interesting chip. If I just bring up the data sheet, there we go. So if you have a look at it, it's actually a the right bit of the screen. Right. It's let me see if I can control the mouse. It's a CMOS counter. Yep. There we go. So its operation is actually relatively simple. It starts off at 0, and every time you clock it, it moves, next one over. So, this goes high, the rest low, and then 1 becomes high, the rest go low, etc. Then when you get down to 9, it drops back down to 0, but then also asserts the carry out. So you can use that to then clock the next chip. So this can be the ones digit, and that'll pass on to the tens digit. So every 10 ticks of the ones, it'll then clock. So you can then chain these one after another if you want to get multiple digits. Reset pin, if you hold it high, resets everything back to 0. Clock inhibit, if that's high, it'll just ignore the clock. If that's low, every time you pulse the clock, the digits will move on one. So, relatively simple chip. Quite useful for this sort of thing. So, switch back to the system. What you can see here is, so this here, and rather than going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, they're all scattered. So pin 3 here is 0 pin. If you trace it around, it'll turn this one on. So this transistor will be on when the chip's in state 0. Then it switches to 1, which is then pin 2, which is this one. This one will come on. So 0, then 1, then 2, then 3, then 4, then 5, then 6, 7, 8, 9. So it'll go up and then go down and then start here again. So it'll go up and go down, go up and go down. So I'm expecting the LEDs will go from, let's see, that's inverted. So I'll start here, go A, go down, up and down, up and down, up and down that way. And then the 555 is supplying the clock signal. So you trace the circuitry out, you come up with that. And if you go online and have a look, that is your standard oscillator for your 555's layout. Pin 1 is to the ground, pin 4 and 8 are connected high, 2 and 6 are wired in between the resistor and the capacitor to the ground. And then if you go through, this will tick at about 7 hertz. So I expect it'll tick 7 times a second. And then what they've done is they've just pulled the clock pin off for the 7014, off pin 3. So this will set it ticking away, and then that link chip there will then link over to the clock pin on this, which will then pulse this 7 times a second. So I expect that it'll move up and down, up and down, up and down. 10 of them, about 1.3 seconds to go all the way backwards and forwards. So it should tick along quite nicely. So got my soldering iron hot, got my solder. Let's get going. So first off, let's get these bags open. Get that off. Enough. And rubbish. What we got here? Solder, 6040. Nice chunk of leaded solder. My own, thank you. What we got? 555 CN and a CB4017BE. Okay. Couple of pins, so those would be for the mains 12 volt in. A whole bunch of LEDs. A whole bunch of transistors. Okay. We got switch. I suspect they will all be 10K. 2, 4, 6, 8, 10 of those. So that'll be my 10Ks. Input diode. 2, 4, 6, 8, 10 resistors. Resistors? Transistors. Switch. What we got here? 16 volt, 47 microfarad. 63 volt, 1 microfarad. Yep. And 16 volt, 10 microfarad. Why do I go to the 63 volt one? Here's a 1 microfarad over. Well, I suppose it is between mains and VCC and ground. There's ground coming through there. There's the 1 microfarad there. Where it's 1 UF. Oh, the 1 UF is here. Okay, that's used for timing. So the 1 UF is used for the timing circuitry. The 10 UF, 10 microfarads is the input smoother. And 47 is down here. Intriguing. I have a link, apparently. What does it say here? Resistors. Yeah. 2 pins. Yep. 3 here. So the first one is a orange. What's this one? Orange, orange. No, brown, brown, black. Brown. I turn the right way. Red, red, black. Red, red, black, brown, brown. So that is my 2.2K. Oh, I need to put my glasses on. I hate getting old. Oh, what's this one? This one is a brown, black, is that way around? Brown, black, black, orange, brown. So that's my 100K. And this one is a that's it. Yeah. So it's my orange, orange, black, black, brown. Orange, orange, black, black, brown is 330. Now, if I go to this, I should have a link. I don't have a link. Should I have a link? No, apparently I'll just have to use one of the component leads for that, which is fine. Right, I need a pair of wire cutters. Back in a second. Pair of wire cutters, and somewhere around here I have a component lead former. I hit it just before. Okay, using my component lead former. I had it. I put it to one side. I made sure I had it out. Okay, this is getting ridiculous. Oh, there it is. I put it to one side so I wouldn't forget where it was. So it's one of those. Right. What do you reckon we tackle first? Let's get all these 10Ks in. Okay, so what's this? What are you looking at? No. No. Yes, it's going to have to be wrong. It's the second one. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the one that fits. Yeah. 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 I was watching a Big Clive the other day and he was doing a whole bunch of resistors. There's a really neat little tool that forms, trims, and cuts resistor. But looks like the tool's gone out of production and no one's making a knockoff, so a bit annoying. I don't know if this is doing a reasonably quick job, but there's lots of trimming once it's finished. We'll do that. Let's 10 of them. And let's see, let's make sure they're all the same way around. And yes, I've also got a hopefully it's not audible. I've got a solder fume extractor here. I noticed in my last video there's lots of fumes flying around and I don't think they're, well, what little bit I get exposed to is going to be a problem, but, you know, you might as well not risk it. It just sucks it away and blows it through a carbon filter and then dumps it out the far end, so... But luckily I'm in quite a well-ventilated shed, so... Hence the acoustics at times aren't great. We don't have a purpose-built lab, unfortunately. Be nice, I suppose. That's all the 10Ks in. One more. Alright, what next, you reckon? Let's get all the resistors in, why not? So this one was the red, black, brown. Red, black, brown is my... Was it 2K? 2.2K. 2.2K. Where's that? Here? What else we got? Brown, orange, I think it was. Nope. Brown, black, orange, brown. That is my 100K. It's over here by the 555. Remember that. And then this must be my 330. It's orange, black, brown. Orange, black, brown is in fact my 330. So that's just a current limiting resistor, so it'll limit how much current can flow through all these LEDs. That looks pretty good to me. And what I will do is somewhere, where's my box of... I'm going to put my box of bits. Oh, I'm having one of those days. Oh, there it is. One thing I do is I keep track of all the component needs. I trim off for this exact purpose. So, let's see. Something silver. That looks pretty good. And let's go there. The staple can go in there and there you go. One wire link. Oh, and another wire link. Where's that? 2 links. Got resistor legs, these ones, actually. And hefty and solid. At least they've kept the spacing nice and even. Right, is that all the LEDs? Sorry, LEDs. Oh, grief. Go now. Right. That will go line to line. Ooh. Oops. Oh, no, it's the wrong size. How did I do that? Just when I was suddenly complimenting on nice even track spacings. There we go. That is all those ones. Yep. All right. Let's get them in. Let's see how well this solder extractor does. It's the middle. Yep. All right. Let's go. There's a line. Any sideways? It's a relatively new board, so the heads are very nicely tinned and nice and silver. No tarnishing on them. A couple of the kits I made recently had very tarnished pins. Um, mm, 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 mm. I was talking to someone the other day and I asked why I use such fine solder. Fine, because it's easy to put not enough on and put too much on. And if you don't put enough on, you can always add more. That's a pain in the bum to take silver off. Silver? Solder off. And yes, that's what I got used to over the years. I do also have some of the thicker stuff, which is useful when you're tinning wires and stuff like that, and you want to feed a lot of solder in a lot quicker than this. This does tend to be feeding a lot, and you realise it's only what, 0.2 mil, 0.3 mil thick, something like that. It's not very thick at all. It melts quick as well, which is nice. Yeah, almost done. Oh, links. That one. That one. How are you looking? They look pretty good to me. Yeah, going sideways. Nice. Yeah. Ooh. That short's one or two. By short, I mean not enough solder. Just need a bit of reheating. Very nicely. Yeah, they all look pretty good to me. All right. Let's get this hot trimmed. You never underestimate the value of a decent pair of side cutters. Even though they're nice because they actually cut fairly flush. Brand of these. Wolston, I think it's a UK brand. Going to be corrected. Okay. Get the joints, they're all look good to me. Go for my little box of bits. Keep them nice and safe. Right, there we go. That looks pretty good to me. So, what do you reckon next? LEDs or transistors? Who's got the higher height? LEDs. So put transistors next. What have we got? 1, 2, 3. So they sit nicely. Yep. So yeah. Been interesting getting back into the old circuit analysis and trying to figure out how these things work. I've got another kit which I'm going to build after this one, which in fact has another of these 4017s on them. And it's a interesting circuit. It took ages to figure out how it worked. Yeah, it was an interesting circuit. It I won't go into spoilers, but it used a very interesting decoding mechanism. basically encode state machine, I suppose it was. Yep. Basically encoding a state machine onto a circuit board, so it was really interesting. I mean, this one, once you sit down and figured out, well, it's got 10 circuits on this side, which are identical, so that's half the board done. 555 timer, once you figure out the bits and pieces and what goes where, there's a book I got a copy of years ago which has so many variants of the 555 timer and circuits you can make. So you get like a monostable oscillator, one shot, so you press it, you'll get one pulse of a known length of time. So that was quite interesting. But yeah, it's well worth it if you're ever starting out. Here's a 555. I bought 100, I think it was, on eBay for probably about $20 years ago. I'm sure half of them are dodgy, but that's really even. Let's just put the LEDs in. So this is an interesting tool. I picked this up the other day, an LED tester. You just get it, and nope, long around. So that shows you how bright it is at 5 milliamp. And then you go 10, a little bit brighter. Oh, there's 20. And it's 35, and then all at 50. So it's a nice way of actually just going through and checking how bright my LEDs are at quite a few of the common ones. And we've got 2 at 5, so you can actually compare them, 2 at 5 and 2 at 10. So you can put 2 LEDs in and see which one's brighter or not. So for these, long lead is A, short lead is K, anode and cathode, and circuit board quite neatly shows you A at one end, K at the other. And also if you look, there'll be a flat. So there's a slight flat edge on that one. So K is your negative, I think it's. There we go, all the way down. Let's just look at it. So what I'm saying, A is long, so long. So, yeah. That way. I built a circuit board the other day. I say the other day. During COVID, actually, isn't it? UV. I wanted to get some near UV LEDs. And I wanted to put them into a 16 by 8 array. I ended up with thousands of LEDs, well, hundreds really. I'm trying to get them all wired in the right way, and I got them all done. That was an epic afternoon of. No. It's going to sit, or are you going to not sit? No, not quite. No, we'll see how we go. I think they're not quite going to sit. Let's just get them all in, and I'll sort them out. But yeah, it seems to be absolutely forever with a bit of Vero board. Solder. Run the LEDs up. Alright, that one doesn't work. Check it. Because I wasn't 100% sure what quality they were, so I ended up with a few duds, and she sold the wrong way, and it was working. Actually worked really well. And I used it to charge up fluorescent paint. So I had a whole bunch of, well, it was actually fluorescent powder, and that could glow in the dark. So put it under the UV lamps, sit them there for about 10 minutes, shake it all up, and they used to glow for a good 20-30 minutes with a couple of minutes of UV. So it looked cool anyway. Right. Let's see. They're all going to sit really down. Yeah, that's enough. Nah. Of course, they'll all fill out. Let's have a look. Which ones are causing problems? Right. Looks like it's good enough. There we go. So that one's with them. There we go. Come on. Right. There we go. That looks like it's all sitting pretty much down to the ground. Let's get that slot tacked in, and then I can check them all. If you do sit here and watch this and we get to this point, please feel free to point us to any direction of any kits you've made or something like that, because I'm always interested in that sort of thing. Trying different bits and pieces. I am, at some stage, going to get some surface mount stuff to solder. I'm slowly setting up the lab for that. Next. I don't know if I'm going to go whole hog and get myself a toaster oven or anything like that yet. Might try a bit of the old hot plate soldering first. See if that works alright. Seems to. Yeah. Wow, these LEDs don't seem to want to solder, right? Some of them don't. Bucks on a minute. Halfway there. Actually, it's slightly noisy for me. I don't see it being picked up on the microphone, which is good. But I will check the recording. The solar fan here is actually keeping the fumes relatively nicely out of my face. So, take that as a good positive. Almost done with the LEDs. Someone definitely want to solder up, and someone want to be annoying. Yeah, it's not perfect. Alright. Let's have a look. No, apart from that one, that is a bit off. Not great, but not bad. That'll do. Right. Let's trim this all off. these two things. Oh, I don't know at the moment. Oh. Definitely some of those connections need a bit of a checking. Yep. Yeah. It's fine. Right. How do they look? Actually, is where was it? If it needs a bit more, really, it needs a bit more solder. Looks a bit dry on that one. A little bit more. That one. That looks. Cool. Right, let's get these transistors done. And we got chip, and we're almost sorted. Couple of chips, switch. Oh no, I can LED. LED 21. Ooh, you snuck out. When you point out that to me? Probably were, but never mind. Yep, I got it. Yeah. So I think the idea is these will go all the way up and down. And then later on, if we want to, where is it? There's 100k. If I bridge that with a variable resistor, I might be able to control speed. Yep. That's for playing around for another day. Let's get these transistors on. Oops. Brass wool. Yes, some of you are told about transistors. You want to be quick, you want to be fast, and then I'm thinking they will burn and die rather quickly. I'm going to get one or two that don't. Okay. Oh, great. Two of these look atrocious. There we go. And done. Not too hot. Let's stick out a little too much. Yep. Still stick out too much, but a little bit. Quality control's not great. The short solder joints are adequate. The component perfection, high perfection. It's not brilliant. Yeah. It's not triggering my OCD too much. So. So get all easy. Oh, no, no, got it. Look useful. 40 minutes in, I'm going to have to speed up some of this, I think. But, I suppose you let me just spin on, can't you? Nice thing about YouTube, you can always just spin on or fast forward or whatever. I've got short down to check that. Any shorts? Yeah, looks so. I might just avoid them. That spacing is icons, anyway. No. 30 pins later. Looks reasonable to me. No shorts, no cold joints, no. Right. There's a bit of flux here and there. Cool. So we've got a mess apart from that. We've got 1 pin, 2 pins. So let's get those in. So they're going to get some thermal mass on those ones, right? Right. Hot, warm, out, hot, out, very hot. Ooh, out. Okay. Don't pick up something that you've touched with soldering on for a period of time. Does they have a habit of getting hot? Very small? Yep, hot. Okay. How many times have I done that in the past? Right, I'll sit there. Cool. Let's get these caps in. So what we got? This is a 10 UF. Let's see, 10 goes here, negative set sign. So too much pressure on the wires. This one is the 47. Goes that way. What brand are these anyway? Suntan. Okay. Yeah, but it's -3. Yep. Not for that one. Okay, that's all kept on. That's for them done. Almost there. One thing that is nice about giving you multiple holes for each component. So if you get a capacitor that's got slightly bigger leg, bracing on those. That look good. Yeah, so if this capacitor is slightly wider legs than before, there's extra holes you can put them onto, which is nice. That's alright. Okay, so what we got left? That and oh, 2 chips. That's this. Sweet. Let's put switch in. Get that done. No. Could be lazy and do a couple of legs. That's good. Yeah. Yeah. Stuck. Right. Actually, this is a one-time. The slightly thicker stuff. I think it just works better on these components which need a bit more solder. And then I'm not wasting my stuff. It's funny enough, a little bit of solder is getting hard to get hold of these guys. Pressing down on it. But, the amount I use over the years, I've got what, 2 kilos maybe at most. 5 for 5. C141. And this whole bench is actually just anti-static, so tested annually. I believe I actually test it quite often, but yeah. Right. And my pin strainer at some stage. It's 5.5 in anyway. It's just old school time. That's the right way. So you want to get notch to notch on the diagram. It's pin one right. Oh, come on. No. Get the inside straight. No, that's fine. I'm gonna slide in. I'm gonna slide in. You will slide in. Come on. Should put this in for the cap. So I should put this here. It's just proving to be a little bit tight. And if I was doing this, it possibly even put a socket in, but Better. Just one more. There we go. Let's chip in. Let's get him soldered down. Let's power up. Let's see what happens. Oh, I've got to go to that link. Why didn't someone tell me? Right. Five. Now, if they've got the footprints correct, quite often they've got a square on one. Whose kit it was doing a few years back. There's no indication on which way the trip had to go. So I ended up spending time actually sitting there and tracing power lines, just trying to figure out which ones are which is positive, which is negative. Oh yeah. Alright. I think that's it. Quick check. Yep. No parts on the bench? Nope. So if you can see how that pin and that pin are shorted with the circle, which then goes onto that rail there. That's your negative rail because that's your clock inhibit and that's your reset. So you both hold those low, and that's your clock coming in there, which there's the link into the 555. So that's your 555 section. That's your digit counter, and that's your switching. So let's turn everything off. Turn you off. Works, but it's noisy. Right, let's see. Negative to negative. Positive to positive. We've done that. Stop it flying around. Right. No, not 15 volts. 12 volts. It was 12 volts, wasn't it? Yes, it says on the board. 12 volts. Let's see what happens to it. And then to flick the switch. It is working. Can you see that? No, you can't. Right. Light's going off. Let's see what happens. Oh. Okay. Change of plan. That actually turned off my power supply. 12 volts. No, I want 12 volts. Let's just try turning the lights off. There you go. Oh. So, my supposition is if I change that resistance there, this should speed up. So let's see, that's 100k. We'll put 100k. Oh, turn this solder on off. We'll get another 100k and short that. 100k in parallel. Yeah, 100k. So what I've got here is another 100k resistor. If I very carefully short that across the, drop it on the board and short everything out. I very carefully short that across that one. Speeding up. Oh, there you go.
Speeding up, slowing down, speeding up.
Okay, so it's drawing, what's it, 35 milliamps? Yeah, it's not bad. So there you go, guys. Hope you found that interesting. Standard little circuit chaser. But yeah, using one of these chips is 4017, which is a nice little chip. Neither of those are getting hot, which is good. But yeah, hope you found that interesting. Hope you found that enjoyable. I'll like and subscribe on YouTube. I am on Twitch. Don't do any electronics on Twitch yet, but if enough people are interested, I might do some soldering live or do some circuit analysis live if people are interested. But yeah, there we go. Fun little LED circuit, which will just sit there bouncing backwards and forwards. I reckon it's easily hackable if you wanted to change the speed or do something else with it. Yeah. Might be an interesting one to actually change colours and see if you end up with a rainbow chaser. But you can actually see that if you put this in like 2 circles, you have the LED. Actually, if you split it up into a circle, you'd have the LEDs chasing themselves around in a circle if you wanted. But yeah. Anyway, hopefully you found that enjoyable. Like and subscribe on YouTube, and I'll see you later. Bye.